Good afternoon, everybody. And as you know, we are going through a online course. It is a 167th IIRS outreach program. The title of this program is Archival and Access of Space Science Data. So one of the very important aspect of this is access of space science data. So the lecture number 3, which is I'm going to deliver today, is Introduction to Science Data Archival and Standard Practices. Also, I'll be touching upon the main theme of this program is how you can access the space science data. So welcome to you, myself Himanshu Pandey, taking care of the space and data center activities at Bangalore. So before starting, I just want to give a glimpse to you what is ISDC. ISDC is actually disclose science data quickly to scientists, students like you, various institutes, professors, general public, researchers, principal investigators, guest observers, and many other people. Even anybody can access the data from ISDC. It is actually ISRO the repository of space system. So to host this archive or to host this repository, it is coming from a standard data center. So what is data center? A data center is a centralized repository, either physical or virtual, for the storage, management, and dissemination of data and information organized around a particular body of knowledge or pertaining to a particular business. This is just standard definition. So if you see, there are many types of data centers that exist here. So same way, each and every data center is having a specific purpose or service to be delivered. So in the same line, this particular Indian Space and Data Center is also designed to host a specific service to achieve a defined goals. What are these things? This is some general like topics which I will be covering. So the main thing is objective to facilitate data ingestion, processing, archive, and dissemination. Generally, we call it as an IPAD service. I'll be explaining this one also to you. This is the main objective of this particular data center to serve these IPAD services for all the space science mission sorts. With the vision is to extend the services for all the interplanetary missions, lunar missions, human space flight programs, space science missions, and other deep space missions with state-of-art technologies. So main thing is we have to keep on adopting new technologies and keep on upgrading the data center as well as services. And also, what is happening in the world, we have to also collaborate with them for science data centers of world and also facilitate quick availability of data to the users and the community. Just to give a glimpse of ISDC, the current status, it is a prime data center for lunar interplanetary space science missions. It was actually established in the 2008. The photo is visible towards right side. As of now, Chandrayaan-1 was completed. There was one more mission, which was having a very specific payload from Canada on a resource satellite, then NewSat satellite, then Megatropics, Mars orbital mission. There is another INS-2PD, Chandrayaan-3, in which lander and rover modules are completed, and INS-2B, which is Bhutan-SAT, which is also called as Bhutan-SAT. As of now, ongoing missions which we are currently supporting is AstroSat, Chandrayaan-2, Aditya Album, ExpoSat, Chandrayaan-3 propulsion module. I think Chandrayaan-3 was having 3 modules: propulsion module, lander module, and rover module. So now propulsion module activities is still going on. In addition to that, SpaceX-A and SpaceX-B. We might have heard about the docking experiment recently conducted. So that is also being supported through SpaceX-A and SpaceX-B. The upcoming missions which we are already discussing and targeting is Chandrayaan-4. Chandrayaan-5 is a joint mission with the JAXA. We might have heard during November's presentation. So that is also called Lunar Polar Exploration Program in a collaboration with Japan. Mars landing mission, Venus orbital mission, and also here there is a SpaceX-3 and SpaceX-2, 2 and 3 both are also lined up, which we are also discussing as of now. So the prime function of Indian Space Data Center is data ingest, processing, archive, dissemination, web application testing, mission-specific data pipeline, application development, IT services moderation. So when we say data ingest, you see, we may have to receive the data from any of the ground station. It should be in some standard format, it should be in some order, it should be acceptable to us to engineers to should be able to verify the data and we should be able to understand the quality, all those aspects are coming in the part of this data ingest. And we have to work out the architecture that I will be touching upon in some of the slides, how the architecture will be evolved. Then coming to the data processing, there will be initial level data processing, then higher level data conservation, then level 1, level 2, and I mean, all those things, archives also getting into that is part of data archive. When data is getting ingested and processed, immediate data archives are getting generated. They are called an active archive. Once active archives have gone through proper checks, verifications, completeness, correctness, and consistency. And then they are to be, after every proper review, to be treated as a long-term archive that also need to be posted and managed in a perpetual manner. It should be kept permanently here. Then further data dissemination. There are different requirements, how it should be disseminated, policy-based dissemination, or dissemination in general base, like all these things are coming in a part of that. To do all this activity, we have to develop so many internal applications which are based on various missions requirement and data center requirement. Various web applications for different purposes. Various mission specific data pipelines for each mission is having very unique requirement. All these things are implemented. And then lot of part softwares are implemented for IP services and automation. In addition to that, we are also venturing into the data science and analysis activity, which definitely all of you and students also can participate. They can approach us. They can also join us and do the activity in a collaborative manner via the science program office or ISRO. So coming to the standards, you see, one of the most important standard in the planetary domain is planetary standards. I hope that yesterday our colleague Mr. Ajay might have touched upon the planetary systems. So I'll be touching only briefly on this. These two topics were also put as a part of this PPT. So these two you might have gone through yesterday completely. So when you say, I will just top level briefly tell that all planetary data missions are following the planetary standards. Here various levels are there, PBS3, PBS4, and so on. So as of now, PBS4 is the latest standard, which we are also following the same standard for our Chandrayaan missions. And SPICE is actually a standard which is used to keep the spacecraft meeting information in a standard format so that anybody in the entire world they will be able to interpret the data and will be used. But in addition to that, when we say that archival formats, there are various other missions are there. If you see there are solar missions are there are astronomical missions are there are some Earth observation science missions are there, like weather topics of weeks and other things. So what about those things? Then there are solar missions are coming with it. So for that, archival formats are like this, like this. This is a flexible image transformation system, which is best one of the very popular format which is acceptable by the scientific community in the astronomical domain. Then there is a hierarchical data format, SD5, max serial, IMG, image, cube is like multi, here, DAT files, then tab file, TXT, CSV, GOT. These are various archival standard formats are there, which are being used for various scientific missions. And then there is a PDAP protocol, a planetary data access protocol. It is used for accessing the archives from different space agencies, and you can search the data based on similarity data and get back data. But whenever you don't have any specific standard, what do you do? We have to fix one of the standard archival format, which is actually being followed up or accepted by the scientific community. Like, for example, like astronomical community, they knows very well the fixed format. Same they if we go for Earth observation, these type of missions, they are archival format like SD5 and HDF. They are very popular and people are very, you can say, used to these formats. So then we have to accept and generate the data products only into the scientific committee accepted formats only. Now coming to this one, when we don't have a PBS and these type of things to follow, then we have to follow standard structure directly so that our archival and retrievable things should be in a very interpretable form. Okay. So now coming to ILDC, you will be seeing this one of the image here on the screen is a big campus here, which is located around 35 kilometers away from Bangalore. And this is the center usage ILDC, and we are co-located with the deep space stations. It's called as you can say India's gateway to deep space. very big antenna and deep antenna. There are two more antennas are there. This is a new DAP, new DAP station, and there are some lab antennas. So she is located here. So we are co-located. So for all space science missions, data will be received here and immediately it will be back to the science person locally. So this is some of the glimpse of our ICGC. And the main function for data center is like multi-mission automated data pipeline, fault-free operations, data dissemination interface extension with remote operation centers, PIs, and email notifications. Better scale, high scale performance storage for multi-mission. Three-layered network domain with frenzy. You see, whenever we are making a data center, we have to see what are the requirements for a data center. So when we worked out, we saw we have to interact with control center. We have to interact with the various ground stations, whether it is Indian ground stations or foreign ground stations. We have to also interact with various POCs, various principal investigators. We have also interact and post the data for genuine public and users. So when we have this type of varied requirement, we have to take care and ensure that the data point generation, ingestion, everything should be protected to data. So ultimately, it has been divided into material with various defined functions. So these are some ceiling features we told. So internally, when you want to develop and generate a data product, so high-end SAN environment was applied. And for dissemination purpose, maybe a moderately sized mass environment was designed. And continuously, we have to upgrade our data center for new missions and ongoing activities. In the science mission, very specific thing is the accuracy, the involvement of the product verifications and reviews will keep on happening on a regular basis. So whenever there is this one, the reviews are happening, there will be some suggestions and inputs will come. So in such case, if at all anything is being suggested, it is very relevant, it is required, we have to regenerate the entire assets. We have to generate a new version. So in that case, the data center should be capable enough to provide the entire environment of generating the data sets of maybe sometimes in thousands or going around in huge number, which need to generate it in a very time-bound way. And then to protect from outside internet-based access to our internal mission network-based, we have our physical boundary gateway, which is only allowing us to give data from inside to outside, outside to inside only in a one-way fashion to our to work as a data direct. And then there is a healthy storage management, the clear storage. We are also a little bit, I'll just explain you in the subsequent slides, and then multi-homing network. You see, when I'm hosting the services to our users on internet, you see, I should have a multiple internets in the device. So in that case, if at all one internet is down, second internet is taking care of that service. So we have hosted our configuration in a multi-home network where our services are seamlessly hosted on any of this and context switched to this one to ensure that connectivity of the services to the users. Now, whenever data is coming, the most important, very important thing is to understand that we are seeing the right direction. We have to do a primary investigation. We have to also understand that right mode is getting operated. It is not saturated in something. So for that, two big physical provisions are being made at ISRO in coordination with various ISRO or the partners also. Sometimes their softwares are also coming in India. And periodic refinement of ISRO architecture. Then we are also interacting with various space agencies and industry institutes for the data exchange. And regularly, a lot of things like we have to do one IT security and assessments, release different applications, and also do a software. So top level, whatever I told, IAP, here you see ingest may be for payload data, ingest may be some auxiliary data, which comes from the spacecraft, and it may be received in any of the ground station. Processing may be a quick display processing, it can be level 0, level 1, it can be regeneration of the data set, registration, most likely browse, and archival means we are just storing the data in as per our data structure or in as per some archival plan, which we are picking up as a international standard or long-term archive and follow various international archive standards and adopt in our environment. Dissemination is only policy-based dissemination to innovation centers, AIs, products, browse products, and IT hosting to general public. A typical pipeline, you see, you have already attended some of the lectures, but here I want to just highlight the entire flow of this. So typical flow is whenever data is coming, from a satellite. So if you see here, where I have mentioned here ground stations. Above ground station is satellite. Satellite will give data to the ground station. So when I say IDSM means deep space missions for the deep space missions, IRS stations means for other missions like AstroSat or another topics or the ExpoSat. So whenever satellite is giving data to ground station will have two categories of data. One is called telemetry, means which is containing the satellite's subsystems health data. Is the first data. Second is each satellite is having a lot of instruments also. So the instruments is also called the payloads. So this payload data will come from this. So there is called telemetry data, which is containing subsystems, so many subsystems, their health data, and so we have a control center here. It is called mission operations complex. So the telemetry data would be here, real-time telemetry data through our own softwares. It would be sent to the control center. From there, people will be sitting there and they will be doing the commanding to the satellite based on the requirement, and they will be monitoring each and every parameter of the satellite. Then all these files will be archived, and the actual activity also will be sent to the MOS for permanent archive. And one copy is also maintained here in data center. Now coming to payload data. Whatever payload data will come, there are three ways it is coming. One is the real-time payload data, which we are feeding it to the servers, and then offline payload data. Offline payload data is coming to the servers. It would be one copy would be sent for archiving, another copy would be given to the level 0 processing. After level 0 processing, it would be given to level 1 and level 2 processing. Level 0 processing also one copy is kept for archiving, second copy is given to level 2. And also it is being sent here through our secure data diode through file transfer system. It will go to our destination domain, and from there it is being sent to our partnered PhCs, like yesterday from SAT, like that. That is even tomorrow some presentations are there. They are also all our connected POCs data. And then storage, all data will come here, and then automatically data will be taken on a disk backup, and then it will be taken as a tape backup. So this one is a typical pipeline. And you people, as a users, you are connected here. You are connected, and you will be accessing one of the applications here. Now coming to our foreign stations, whenever data is getting a satellite is getting dumped or data is getting dumped here in the foreign stations, they are also connected to here. We have a separate chain here from here only data diode. It will come inside, and then again it will be fed here for the subsequent processing, not table, and for the resiliency. So that is what is happening. So now coming to the particular lecture, what I have told. First, we have this water data ingestion network. Second is change data network. Third is data exchange network and data dissemination network. So data acquisition network is actually where the ground stations are acquiring the data and then they will ingesting to your data center. Now coming to each and every layer, if you see here, archives are making the high level data products are getting generated. And then this is the area where between these two data exchange will happen. Actually, these two layers are connected to us through one-way data diode or through, you can say, physical level non-negative oscillation. Now, from here, only the users are connected through internet. We are connected like that. We have a lot of POCs and PAs. They are also connected to us through private links. Each and every layer, there are various applications and services. Everything is being hosted and everything is getting enhanced day by day based on the current missions as well as upcoming missions. So I will not be going through each and everything. It's just a glimpse to you. What as told in the previous slide is between these two, we have two levels of security. One is one-way gateway and another unified thread management devices, which is like a commercial appliance and it is an indigenous service. So now coming to the ingest from the ISRO ground stations. We will ingest from ISRO ground stations, payload data from Indian ground stations, payload data and real-time housekeeping data from IDSM ground stations, offline data from IDSM ground stations, mission operation messages. You see, there are many things, scheduling files, there are tracking files, there are ELE elements files, many things are there which are being exchanged between the space propagation center and the ground station. Those are also going to be the same. Payload from the exchange ground stations via previously you might have seen data exchange and dissemination layer, which is also present in next slide. And the payload data, schedules, navigation messages, operation messages exchanged from the foreign ground stations using various type of communication links. So we are also connected to foreign ground stations through different kind of links. So when we come to the DX and DB and ingestion type of things, there's a different type of ingestion where little bit of Indian constitution over external network. Means through internet also I can receive from some of the Indian constitutions from where I don't have a high bandwidth communication link. I can come through internet or I can come through some other channel like a VRF. Then little data from the foreign ground stations over the link, little data from ground station over internet VRF or VPN links, and tailor data from the foreign ground stations over cloud AWS type of channel, and get data from the external ground stations using there is a standard protocol called space link extension. Then tailor data from external ground station where this there. So effectively, if you see, when we see data ingestion, so there are various things are involved to receive the data from various computations. All those things will be discussed based on requirement and proper workable architecture will be worked out for each and every instance. It is unique and it is separate. So based on that, this would be designed and taken up. Okay. So now coming to quick look display. When we see quick look displays, like suppose I told different stations and other stations, it will come through our switch here, and then we have a quick look servers and quick look lines. Immediate data would be displayed, and finally one link also will be going to the mission operations complex where it will be displayed. There are some ground stations which are near to mission operation complex, it will be displayed directly and sent to mission operation public, and then it will be coming here. So India was both sides. So why I'm telling the quick look display is one of the most important activities. Even when Chandrayaan when first time it has instead of moon, the first data when it came here and people have seen first time from our own instrument, our own satellite, the moon surface. So it was a very joyous moment, and people really by seeing this data only, they have concluded that we have reached to the moon. So this was one of the proof. So that's why before doing any processing, before doing any high level of data point generation, immediately the real-time stream will come and it will be displayed here as a part of this display. Now, once it is displayed, then the main thing is level zero processing. So after ingestion to ISDC, in ISDC area, the data would be given to level 0 processing system, level 0 input area, then level 0 processing happen. The output of level 0 will be given here, and through our FTS and interface, it will go to destination. We have two type of applications developed. One is the file basket system, which is actually doing the entire controlling of the data, the delivery and integrating checks. And there is an exception notification system, which is taking care of if at all in processing anything is failed. It will also capture the regulation support data and also inform the designer that this particular particular thing is failed at so and so level with this error message, and this is the loss like ridiculous fail. And as I told you, there are requirement for regeneration. So we have a separate setup for regeneration. Once this level 0 is happening, next is the same data would be given to level 1 input area and then through FTS and level 1 processing. After level processing, then with FTS interface, level 0 output will be provided with the destination area, and also it will be given to high level data product generation and also any special event or any special data product like Atlas generation or almost tracking or something is required. It will be in case if regeneration is required, a separate environment is created in a campaign mode where high level regeneration. This is a typical chain which is getting executed among most of the specifications. Now coming to archival, how will we do archival? You see, once we do and give the archival, any data ingested or generated ITC, like the raw data levels to level 1 ops file, operation message and other files. First is before even going ahead with the operational chain, together the defining the file name formats and naming convention will be carried out in the other joint activity. After that, we are defining that ITC is a storage area, where which type of files and what will be found. It is an operational setup which has to be followed with some process. So define the transfer paths, prepare the archival plan. This is as per the international standard archival plan or as per the ISRO specific plan that also you decide upon in the various reviews forums and others. And define the retention period for each and every data sets. Then apply the IGC backup policy and verify the data pipeline. Now, if you see all these things, everything is being monitored, each and every orbit. Whenever data will come, each and every orbit or dump or visibility, whatever data is coming in, everything is monitored by your FTS servers. Then daily monitoring of entire data products, area, storage, and everything is done by our student management services. And then retention period is managed by our student services so that after that retention period is over, it can be moved to the backup environment or it can be discarded. All those things are happening. All these elements are very monitored and we checked on a very automatic manner. Now, once we go to this one, the long-term archival. So long-term archival, as I told, that once we have given level 11 data to our payload operation centers. Payload operation centers are there with actually the high level data product generation, data analysis, as well as the instrument designers are also sitting there. So the data after giving to them, they will give the data to us. Or if you say the payload data reception at POC, then there will be higher level product generation with that. And then there would be archive compliance check as per standard. There are various standards, as I told, as per that it will be checked whether it is meeting the standard or not. And after once this is a technical review of the archive. And in Chandrayaan 1, this was done as a part of international community. And Chandrayaan 2 also, a lot of academia was involved in this, even for Chandrayaan 3 also similar happened. Even Archival and Mom also we did same way. The national level, international level release happened, and then after that there is science review. So these two are having two set of teams. In both the teams, POCs and IGC would be a part. In archive checks, it is mostly the archive standards that we are following or not. Then second is a science peer review where the science aspects of the data product will be checked. And after all these feedbacks, quality checks and verification is performed and QC clear. The quality check to get results are reports. So actually, these activities are performed many times due to the mass regeneration or reprocessing of the particular insights. So whenever there is a feedback comes here or somewhere else, an entire thing need to be regenerated, again need to be rechecked. So this is being done in a multiple iterations. After the lock-in period, which is actually a science program office, the first day our IIRS has given presentation from his office to headquarters when clearance is coming, the lock-in period, then data is getting released at ISRO, and then it will be available to all of you. As of now, for Chandrayaan 2, there is no locking period, and for I will just brief upon other missions also. There are various missions, their locking periods are waived off, and you can get the data free of cost at the ISRO website. I will show the demonstration also how you can access and download the data and use it for your purpose. The typical science data management techniques are here. So what we are having is it is more into the they are from computer science background. They will be finding interesting. Others I will just quickly go through. You see, there are two types of storage we have. One is SAN storage, which is a high performance storage, where block devices are being exposed, and there is an ISO and scaled out mass storage, where data is being provided on a LAN through the MS protocol. And we have various stations and servers. Some are in a NAS, some are in a SAN environment. For SAN environments are for generally higher IOPS, higher input-output requirement applications are running here. They are for moderately sized. We are accessing data. And from here to here, and Symphony is required our own software Symphony, which is taking care of high moving between these two. Then entire data is being archived in the tape library. We have two tier 1A, tier 1B as storage, and this is a tape library. So this storage to tape library is taking care. And how the storage to tape library is going is this way. Any file is coming to file system services. It will look in the primary tier 1, which is our main storage. One copy will go to tier 2, the secondary this is storage, and then other copies are going to this is 7. And then the third copy, which is a word copy, every month we are taking a separate copy in the data set. Data sets are like their form proof, part proof, proof, data sets are kept there. So that way it will ensure that the data set. Now there are various missions and having various type of different CPU, the core requirements, operating system requirements, different 10, 20, 100 requirement, lot of memory requirement, different type of things. We also are running entire destination environment in a virtualized this one. So like that, many different kinds of requirements are coming. So we have a all set of things running at HDC and all are inputs. And coming to science data labs, which is very important, and I request all the students and also teachers out there, they also should join this. If you see, one of the important concept of this one is joining the science data analysis. Various national and international agencies has taken proactive interest in standardization of data sharing formats. So, for example, let's suppose if somebody gives X data to Y, then what will happen? Another person should be able to understand it. How you can understand data if data is being shared to you in a particular standard format, and you have a knowledge of the standard format, you have a tools to use and interpret that format, and you have a sufficient environment where you can analyze the data by using a standard format. So for that only there are various national and international agencies are working. Various space agencies has participated and discussed the same thing form several data exchange protocols to develop a strong science balance for science community. Establishing a data system driven community needs with reliable high performance computing facility and data storage. That is what we are also participating in doing and supporting this activity. Now, availability of coordinated and user-friendly analysis tool with documentation describe the data products and such. Here also we are coming to the picture, and then flexible, interoperable, and interconnected data archives and modeling centers and virtual capabilities. When we talk about this means, you see the data if you receive from ISRO or from NASA, JAXA, ESA, anything, if it is a linear data, all should be in the same format. You should be able to interpret and interoperable. Data from this also you should be able to different agency also should be able to use. So one of the important that type of alliance or you can say agency is there. It is called International Planetary Data Alliance (IPDA). People will also can look into its website. This is IPDA JPL NASA.com. It was actually studied by NASA, but now there are so many partners, so many agencies are participating. NASA is in the lead role. So regularly they will be conducting discussions, meetings, workshops, and all these things, and they will be improving the standards. They will be doing engineering into the different formats and generating it to ensure that today you are using the data into your system. Uh, Tomorrow, after 10 years, 15 years, 25 years, if somebody else is also using the same data, they should be able to interpret, they should be able to use the data. It is the ultimate goal of this particular thing. Because today operating systems are changing, tools are changing, libraries are changing. Same older library, if you're running a new operating system, it may not work. But it should not happen with the science data. So for that, these type of alliances and standards need to be worked out. So if you go to the partner agencies, you see ISRO also is there in one of them. So like that, many agencies are there, they're participating as a part of this one, and they're evolving these standards, and we are also one of them. So if you see, IPD's main emphasis is to discovery, access, and use of planetary data by worldwide scientists, and they are developing an international standard with the most common methods for collecting and discovering planetary science data across international community. And they are also focusing on long-term goal of using the data sharing access system across different agency boundaries. Okay. So when we go to the access to data, there are all archives are existing. So some of the students may have doubt. Like suppose if you see solar systems, there are Mercury, Venus, Moon, Mars, Ceres, asteroids, Sirian system, Saturnian, Uranian, Neptunian, comets, and Plutonian systems like asteroids. So all these tables so that these data sets you want to access. Somebody wants to work on suppose Mars. What you can do is from IPD itself, we have given ISRO science data. Click on this, you will land to our website. If you go to NASA's planetary system, you will land to NASA's biggest system. ESA's planetary science archive. JAXA's archive. DART is a DART system in JAXA. Then UAE Space Agency archive and your planet PESPA. So these are different archives standards, and click on this, we will be getting the data from all these sources, whatever their agencies have supported and posted. So the very single place you can use that. So if you click on this, you will land to our also. Then in IPD only, if you see current projects, there are PDFs for implementation projects, data access protocols are there, and you can registration and search, data object identifiers and data citations. There are many things going on. If you want further to do, you can go here. Even you see Ishwar Chandrangan is also mentioned here as a part of your registration research activity. We have done this exercise, the joint one. Now coming to the astronomical data, we have talked about the archive standard for our labs for planetary data. Same way, this is called International Astronomical Union. They are actually dictating similar type of things for astronomical missions. If you say AstroSat or the ExoSat type of missions, they are following the standards which is dictated by them or by the scientific community of astronomical. So generally, they have a IAU, International Astronomical Union FITS working group. The FITS working group is doing the same activity because for astronomy, you can say that FITS is the universally acceptable file format. So if any improvements, anything is required, this is dictated by the FITS working group. Similarly, if I go to the you say Aditya or solar or heliophysics or helio type of missions, it is called International Heliophysics Data Environment Alliance. So there's one more alliance called IHTL. They are also talking about similar type of things. They are ensuring that all the data which belongs to heliophysics or solar science should be generated in a very standard way. So if you see recommendation standards, services, tools, group events, about everything is there. So data formats, case CDF, next CDF, and also metadata is pass, CDF, and DY, object identifiers. And there are various tools are also listed there. Various APIs are also listed there. Some of the agencies are accepting some of the APIs, which you can go through and do it. So in this short span of time, I will not touch upon anything, but only thing is Fits is the most popular, which is also accepted by even a video this team as well. Then visualization tools are also hosted there. You just download it and fetch that, download the data from our website, use this visualization tool, and you'll be able to directly interpret the data because we are already in these formats, which these tools can interpret and understand easily. There are various, you can say, working groups are working on a different aspects, in-depth aspects, so that their job is to metadata. Their job is to coordinate system standardization. Then DOI for sense like that means on every working groups are doing their own job and they are enhancing it, and which we all have to adapt in our environment. Now the link, whatever you have seen, is ISDA. So once you click on that particular link, is ISRO Science Data, right? So ISDA page on our ICC website. So this is our homepage of the website. If you click on this, is ISDA, this is the page. So we will land here. Once we go to the ISDA, all our missions are listed here. You see IIRS, Chandrayaan-1. Further, if you go, as of now, the lunar mission, Chandrayaan-1 is available free first. Chandrayaan-2 is there. Chandrayaan-3 is also available in this. And then then ExpoSat is coming this month, and new physics Archival is there. Then interplanetary is Mars orbital mission. Okay, so now it's no science data archive. If you see Aditya Asteroid Chandrayaan-1, Mars orbital mission Chandrayaan-2, Chandrayaan-3. So if you click on this, further if you go down, there is a playlist. So as per planetary data standard, they are giving us a flexibility to host local dictionary also. For example, like there are some standard metadata, some standard dictionary already released by previous. But if some particular agency wants to add a few more keywords, which is specific to your missions for your satellite, you can work it out and also you can release and post. That is what we have done here. Now, once we click on this, next is ExpoSat. So very soon, maybe most probably in a month's time and so, we are going to release the ExpoSat, but that will also appear here. Now coming to the data archive, as you told, the PDS yesterday, Ajay might have touched upon, I will not put much into this. So it's only we want to say that it is for long-term preservation and maintain the visibility and high quality data analysis. So there will be a structure which actually PDS is dictating. You can refer one of the link. And if you go to the PDS link, whatever the first link I have mentioned here, because it's mentioned here also. So entire details of this PDS is available and about previous nodes, so how it got evolved and how it has been formed. What are the nodes are there which are working on this? Okay, these are all previous nodes in different aspects of this working. And the various tools are hosted here. Actually tools, you can get the data tool, all we are using. And then data standards. So PS3, PS4. As of now, we are in PS4, and earlier Chandrayaan-1 and Mars orbital mission was hosted in PS3. But recently, the Chandrayaan, some of the payloads are already getting converted to PS4. It is being also released to our ISRO website with the help or information with our chat stack. So now, you see, latest mission are placed in PS4. It comprises of data, associated data, mission. So ultimate thing, what we want to convey is just reading data to you is not sufficient. We should have a data. We should have a metadata. We should have an entire mission information. We should have a pure instrument information. We should have a calibration data. We should have a detailed documentation of this data. We should have all the necessary tools, and we should have all the user rights. So this is what our PDS is creating, the second line. It comprises of everything. And different levels of data with a raw, calibrated, derived, all levels are clearly defined and all are providing the different subdirectories. And it also accepts various data formats like IMG, Cube, TIFF, DAT, TAB, CSV, different type of instruments, like suppose imaging instruments. If it is a simple camera, they may prefer IMG formats. That is also accepted. If it is a cyber inspector, it may prefer Cube, which is also accepted. So like that, there are various formats which all are accepted as a part of data products. And then there is another directory also here, which is giving a browse products where only the thumbnails are being kept for the mostly optical tables. You can allow the custom dictionaries, and also you can allow the one-time data you can keep. Like suppose that I will actually touch upon this particular element as explained our demo. This is the type of one of the structure where you can maintain. And then these are the formats. Why want we specifically tell here again is because archival file formats are science and remote sensing community driven and based on wide acceptance by the analyst. Okay, so various formats, we are very flexible, all are available, but whatever science community is driven, that way only the product should be generated and given. So to access and download, the main topic is coming here. There are SFTP based and web based. SFTP HTTP and web based HTTP for general public selected users. SFTP is actually selected users. When they say SFTP, it is allowed from identified node or IP address only. Identified users may log in through provided credentials. SFTP client applications like WinSAP, FileZilla, Webstem, or UDC.org. Open the URL, log in, register, reset, password, all options are here. Select period from browsing download section. Filter the search results based on the various parameters. Or view metadata and file size, select data, and download. You can also integrate with the download manager, download user guides. So for that also, if you see IIRS and IIRS and IIRS all are hosted there. Soon here, exposed also will come. So once we click on any of this one, we'll be on our IGC page. There are various missions are hosted. I will just keep the demo using first demo using Chinman2. If you click on this new details or go to mission and see Chinman2, any of the places you can go. Once you go, you'll land on Chinman2 page. On Chinman2 page, come down to the grid for data access. This is called access here. Since when you go to the access page, it will ask that you are going to the another application because Adan is a dynamic application. These are static pages. So you just click on OK. You will land on Pradan Chinman2. So once you click, this is a login page. You have to sign up. If you're first time, if you're already signed to the Pradan, then only you have to do a login. And one more thing I just want to tell is whatever you have seen the 4-5 applications are hosted for IIRS, Chinman2 all. Once you have registered, you can use and download data with Chinman2, Chinman3 or ASRO this is Aditya interchangeably. No need to recreate an account there. Okay, so now meaning all these things are having a single sign-on features also. And this is another thing which I want to say that there is another application which was released last year within this and the one was map browse. So that in this program you can search the data based on the tabular format, based on keyword and based on various other parameters. You can figure it out. Here you can search the data based on a map search as well. That is the main specific advantage. That also I'll show you some of the screenshots. So if you see continuation of the home page down, if you go, here the information about payloads are given. Browser sends data, select the data based on specific parameters, add multiple filters, download the data in compressed form so that it will be easy for you to copy to your system and pause and resume the download and group small files and download as a single file. This feature also is provided. Videos for compliant archives are available. Such results the pre-tuning, provision tuning data is available and allow for download data also. So to login is here forget password login using. If you are already in an account, click fill your details, click on login. If you have forgotten, click on forget password and then notification will go to the registered email ID. If you are a first time, click on the register. It will ask for some of the, I have just given a screenshot from, but there are so many other parameters. You can give all these values and click on this one, save. And then after that, you can log in there. Once you have successfully logged in, the first thing is the browsing time. We have all these different payloads, class, HSM, IIRS, HDFR, SAP, PLC, HRC, Spice, and map browse. The map browse link is also given from inside as well. So this will be given to compose. Once you click any of them internally, you will go inside the data page, like one of the screenshots of the data page. So once you go to the class data page, the first one, whatever is available is class user number. If you click on this, like the user manual. How to use data after downloading, everything is provided as a part of the Fusion manual in a very detailed manner. It is being updated also frequently whenever there is a change required. Okay. Various references are also available as part of this. Now, one of the cases, like suppose there are some filters are provided, like observation time values. There are so much data existing. So to navigate to your main area of interest, there are parameter list in different for different payloads. The main thing is you can filter search based on the various parameters. But if you select class, there are different parameters. If you select here IIRS, there are different parameters, which so many are there. If you go to the TMC, there are different kind of parameters. So parameter list is different for different payloads based on that. So you can click on this and you can add a combination of parameters to these search results. You see 1, 2, 3, 3 parameters. You can click on something. Whenever this data matches this, whatever entry you have given, then that only will narrow down search results with a very specific value. That is the most important. You can play with this and then get your relevant data sets from there. Now, columns will be added and used from the table listing data sets. The column list is different for different payloads. As I told, in this search results, you have some specific default columns. Now you want to add more columns, you shift it or you can reduce it. Or here you see, for IIRS, there are so many things out there. We have only listed some few things here, whatever will become here as a search results. You can add few more, click, adjust, and submit. Those columns will be listed here and you can export it also. Then coming to the file size, before downloading, if you may have a good bandwidth or maybe less bandwidth, before downloading, you can check whether it is really area of interest to you or not. So for that, you can check the file size, you can check the metadata, and then download the data directly from this one. So file size will go around that 23 or something, this is fine. Then I can check metadata or I can check this one also. Here is an imaging time based. We can understand that this data belongs to, if you see, 2401-2020, 24/2020 belongs to that. So now if you go to the previous level, so as I told you, XML, you click on this XML, there are two type of different payloads we could go. So this is like you are seeing the previous label or you are seeing the XML. When you open this one, each and every information, when it was start time, end time, location detail, if you go down, there's a big list, even the latitude, longitude, corner coordinates, whatever we are talking, even the exposure level, instrument operations mode, everything is listed there as a part of metadata. And if you go to the XML, here also if you see mission type and then your coordinate systems, and then the latitude, longitude, left corner, right corner, full entire box, everything will be mentioned here as part of XML. So you can go through, if really it is matching, based on that, you can enter into your search box and give values and narrow down your search results. Whatever search has come, can list down up to 100 in one page. Also, what you can do is, you can download the data products, one form, starting with one, with size 10, because there are some files, some data products, which are very small in size, like suppose class. So for that, we can download them as a zip file. So for that option is given here. So once you select 100, automatically 100 will come here. You see, download instead. The second one I will show you. Once I selected here, 101 tick. Okay, if you see, select from 185, like that I will show you. 101 tick. If I go there, select from 185, and again, this is the first case. So what happened? It has already selected from 185 automatically. This provision is given in software, and it will keep on counting the size. So as for a very small file size, when it has just 10 MB, 639 up to 639, that's just 10 MB. Then automatically it will take all those things. Click on download. So what it will do is the entire from here to here, this entire file it will copy, make a zip, and it will make it will give you a zip file which will have this data. So it's a complete one. We can have a entire group data label for you for easy download. Okay, now once you go to the previous archive system it uses, there is got ISD emission binding. So why I want to tell you here in one of the slide I told these 2 points I will explain later. You see, there is a hierarchy like the data sets and entirely there are directories and data is available internally. But every time when you download, every time I don't want mission information, I don't want documents, every time I don't want the log information, every time the calibration, all this information, which is you can say static in nature. I don't want it. So what we have worked out is the data products and the corresponding label and browse with the structure. It is available as a part of your search data. When you're searching and the list is coming, you download the entire structure will come. But if you want to have a PDS compliant structure in your laptop or the PC, what you can do is you can do and download this ISRO Science Data Archive Mission Bundle just to download, extract into your system. So it will give you entire structure, including the other documents and downloads and everything. Full structure will get created. And inside data, only this, what you are downloading a data directory, that alone you can go and copy, you will create the structure, which will be PDF for format. So once you static data and dynamic things, both you copy and just copy into the right place. The PDF that we have is also hosted here, is already also available in Master's PDS website, which is compliant to the PDS for, I can say, standard, and you can open it, access, plot the data, see the data, all those things are possible. It is freely available, the free of software. Okay. So that one has to be. Once you open like another thing, IIRS, so it is having a structure, browse, bundle, calibration, data, document, everything. So entire thing will get created automatically. Only thing what you will do is when you are downloading the IIRS data, you copy into inside data. So automatically all data will get copied here. So this structure will get created in the system automatically. Your other download sections, there you will find other things also like handbook, payload data products, science results, various other guides are available, calibration database is available, utilities, softwares, and other documents are also available under this section. That is good. Now, once we go there are each and every payload I'm just showing here. So it is available for you, and it is keep on updating regularly. You can refer this area. In addition to that, there are some L1 files. Means if you say there are some additional files are also available, which are sometimes generated for a specific purpose. That is also available as a part of zip files. Okay. So these are the all data products, archive documents, user manuals, everything is available. We can also see the history and statistics under this section. Once you say download the statistics, and also your history also. You can see what is your own history and documents. Okay. Now, there are very interesting thing is, whenever we are interacting with you, there are a lot of questions with them, how we can access data, how we can interpret data, how we can do. So what to make it very easy, what we have done is, most of the popular questions, whatever we are getting from users in a data access perspective, the science perspective, everything has been put here under common class, all these things, frequently asked questions. You can go through, and if it is like a click on this, it will like expanded view. And then we can see all FAQs with respect to the all payloads, everything is listed. If you go through this, most of your queries and this one will be answered in the first time. After that, if at all you have any queries, we have also hosted a contact section here. So in that contact section, we told for website related queries, you can approach us, ISDC. And in fact, for payload specific queries, we have also listed down all our PIs in the libraries and names. You can approach them and the response from them. And whenever you are most important is whenever you are downloading data from us and using this data for your scientific research purpose, don't forget to give the acknowledgement. So we have also given the acknowledgement statement here for you to refer it. It is available for download, and then you download the content. And in any of the data products or something, if at all anything is there which is not conveyed to you with respect to any accuracy, rights, policy, or something, all those things are mentioned as a part of this framework here. Okay, so this is some of the views which is already available. You can also download and view it. This is a 3D view of Vikram Sarabhai data, which was related to KMC, and this is the OHRC, which is one of the highest resolution data available and released by ISRO on our IDC website. Even small 1-2 meters older also is being you can see from here. From dual frequency SAR from the products. Now coming to astronomical. So you have seen one demo. I have given a very detailed demo of our science data archive access and the download based on the theme of this. So another few minutes I will just quickly touch upon because there will be some repetitions. Again, I will just squeeze it to a few slides only. Now how you can do an AstroSat data. Just you have to go to the IHS website, click on missions, AstroSat, go to the AstroSat page, and you will be seeing the difference. You see, the first of the importance that this was the earlier imaging data, and the AstroSat, you see, highest spatial resolution data is available using the telescope of the same thing. So this has really given a lot of insights to astronomical community and different aspects. So now if you go to the AstroSat page, under Astro Browse, click here, click on OK, you will be landing on the AstroSat Browse page. Give your details, click on submit, login, same way. If you are not logged in earlier, you can register yourself. And then once you go there is a search, and document is also AstroSat handbook is available. You can go through the entire thing, then come to the search. Once you click on search, object name, RA deck. Even once you give RA deck, you can resolve directly from the CMART or resolve from NED. If you give a name here, you no need to remember also. It will resolve already automatically from the existing global sources. Okay. So whatever the payloads you want to click all payloads. If you want to give a specific, it says. Otherwise, if you don't have much knowledge, just click Camera, click on this one. You see RID is already has come from there. Click on all. Nothing I mean click on all search. Once we give the search, entire search results have come back to me. Now in that you see G L1 L2. Just I will touch upon. This is search results. If I click on this file, the file level 1 file, automatically this file got downloaded. Actually, now once I click on this, there are instruments and things are here. So this is their product details. If I click on this, entire product detail is available. If I click on this, map is also available. Immediately on the sky map, this particular data set belongs to what source, or is the astronomical research from which areas. That also you get mapped there immediately. And if you go to the another view, there is separate view also is available. That view was with respect to data is showing here, and this is another view. You can give object some name here. So mistake source name, click on this result, or you can, if you know array, you can give array. Click on this automatically, and nothing view it will go and show that particular area. So that you can understand that in that area, if something is there, some source you want to observe, you can go to search and get a search area and again search the data. So that way you can do the interchangeably. You can use both of them. Like I have your data of the star name result and click on this immediately it has been to the star. Okay. There are a lot of software tools are available here. Even you can go latest version also you can download from the global. These are all freely available tools. And then there are contacts given here. Okay. We can approach to all of the front components. Now coming to the map browse. As I have told you to remind this one, map browse. TMC when you went there already here, it is called map browse. We will link home page of our Chennai to map browse will be available. Once you are logged in, also here map browse. Many places, 11 places map browse. And one more thing I want to highlight is when you log in here, the last release date is also mentioned for all our data sets. So if it is released just 2 days back, 5 days back, so we will know that our archives are up to date. Okay. So once we click on map browse, this page will come, log in. There are some lot of helps also on start given here as a part of this. You can read it and do next, all helps. How to access the data, everything is given as a part of this help desk. Now, if you go there, there are two ways of this one, whatever yesterday I also might have told you. You put rectangular on the globe. This in a folder. So just if you rectangular, if I go, click on this instrument, immediately display here. If I go and tick this and select and download. So this particular data files, whatever I will tick here, see this I have ticked, that strip has come as a array strip. You can click on download, the data will get downloaded. If I go to polar view and click on show, this is I'm showing for IIRS, easy entire data processing. If you click on any of this one, map based, you will be true. Then right click, you can move this cursor on this one and make a square in that area of region, whatever is there, that also will get listed here and you can download them together. So like that, map based searching is there. This is for IIRS and this is for PMC. Now coming to Chandrayaan-1, please know Chandrayaan-1 some 11 payloads for there. These are the data sets for one side of the landing site, the far side of the moon captured by TMC Chandrayaan-1. These are the MIP frames before touchdown on the South Pole checking quicker. These images were given. All those things are available at a part of Chandrayaan from IGC website. When you go there, the Chandrayaan-1 page, these are the links after login. I have not shown here login and all the things to time constraint. But once you log in, these are the all options will be provided to you. You can download that lunar access. It is available free of cost. You can search TMC Horizon. You can also search other EO payloads. EO payloads means which are there are some Indian payloads. There are some availability opportunity payloads which are also provided here. Then dem of 25 meters, dem of 10 meters. Then FNS catalog is available. Spice data, analog data, MIP data, atom data, global mosaic, and all these things are available. And PDS for archives, as we told, it is also available. Now coming to the Mars orbiter mission, this is the typical pipeline which was used in Mars. So here also we told like after POC, this one, it has gone through wellness check and it was made available to us. So this was released by Chairman ISRO earlier and with Sare Jahan by going towards, you can say Mars, photos taken by Mars orbital mission, TZ camera, plus speed next to them. And this is the Olympus small crater, one of the largest crater. And it will be around this 3D visualization. I'm just telling a few things. Now after that, these are MR clause. This is a URL. If you don't need to remember this, you can go from IGZ directly in the here, and it is having automatically archival. It is having one more feature of this map basing addition to the done. So here also right click control, right click of your mouse and then select this grid. And in that, whatever data sets are coming, that will come and will get registered here. And if you click on this one metadata or click on this browse shifts, this browse this one will be able to see. And if you select all and click on with the captcha and click on download, everything will be able to download from here. Then recently, last year, chimpanzee data release happened on 23rd August 2024. So this is whatever is released. By doing any application release, the application would be checked in all aspects. Data archives would be checked in all aspects. Server sizing, first day release, running acknowledgement statements, primary security, then storage, the first release page, and all those things will be done and it will be in the closed watch. So once you say it's in band 3, a lot of like 5 size payloads, how much of the links data, APXS data, NavCam images, then how many modalities were there, total around this much data of science data, how many meters it has traversed, then Ramba, ILSA, and Chastic, all those things were there. In Chennai specifically, lander images, lander camera, lower camera, navigation, and lower images will be done. Then lander payloads for Ramba and Chastic, ILSA, and lower payloads for APXS and emulates. So this is available on ICC website. So once you go to Chimpanzee website, same style login. I want to just here quickly give a glimpse. Because Chimpanzee are 14 days mission, and the size of their payloads are very small. So instead of downloading each day or each file individually, what we have provided is we have given entire data, which is only some few MBs and so as an entire zip file. So that for you also it is easy to download entire data in a single shot. So if you see Rama LP, it is provided with a fully downloadable. Chastic, fully downloadable. ILSA, fully downloadable. Links also, APXS also. But what happened for imaging things, people want to see in picture. LI, Lander Imager, Water Imager, and NavCam. It is provided as a part of separate browsing. So click on this, you can browse and see the image and accordingly you can download. The spice also, it is provided in separate files. Now for live download and install, you can approach us, and with respect to you can say all instruments, there are contacts given. You can definitely approach all of them and based on your query, and then start impacting. Another very important mission in different aspects is the physics mission or Aditya mission. So which is actually operating from the Lagrange point, which is like equilibrium point between Earth and Sun. So they are only the, you can say, satellite is observing the Sun from here in a halo orbit. So this is the Lagrange point. From here only satellite is revolving around this with around 180 days of orbit period, around 6 months you can say. This also was released last year. This was the years released. No web-based access to air. Click on access or login. Web-based access. First home page, all the information about all the payloads are given. So once you log in here, similarly, Lisbon emission line chromatograph, source, solar ultraviolet imaging telescope, solid, solar low energy X-ray spectrometer, aspects, aspects field, aspects there are 2 different scenes, both are separately provided. Then renewals, Papa, Mac, and all. So some of the instruments what you are seeing here, even AstroSat or whatever, tomorrow Dr. Dinesh also is going, once you download the data, what next you will do? So tomorrow you are going to see the data analysis aspects of a downloading data from Dr. Girish, and later I think from Dr. Dhanya about Papa, Menka, and all the J's, all those aspects you will be seeing from Dr. Dhanya. Yep. So this is the thing what I was telling you. Once you click on source, so user manual is available and there is a preview. Other things already I have read in the previous sessions, like info. If you click entire information about this payload and the file size and filter name, everything is available. And by seeing this also, you can make out this was 20th December 2024 data sets. But only thing is, if you click on this, then so you can zoom out, all those features are available here. And the main thing is contacts. So all our peers, principal investigators, or peer specific team members whom you can approach for interpreting the is also mentioned here. And then another very interesting mission, for which data is expected to be released very soon. But in the meantime, there is an Expo Viewer, and Expo we already released on 27th March. Okay. So this is called export set, sensitive memory suitably. But for accessing this data, you can refer demonstration of Pradhan as a part of channel to whatever you have given the demonstration. But here, one thing I just want to convey to you is if somebody is interested, there is called proposal processing system. There are some missions like AstroSat or Aditya or ExpoSat. They are scientific community driven missions for which what happened, this mission is going to see what. So you can register and you can submit your proposal. Like I want this particular instrument should see this particular celestial source for this much period. All those things you can do. You can contribute in submitting proposals. So that only I want to say is there is a step here. You being sitting here, POCs, PIs, any guest observers or anybody, you can submit a proposal to our PP system. Same thing is implemented for AstroSat also, which is getting released very soon. It is under some more evaluation. And whatever I'm showing here is already released recently in March, and it is already people are submitting the proposals. So once you submit the proposals as create users or as a public users, is any of you can submit your proposals. Then what happened? There are community mission managers also. All these things will go as an input into our database, and then it will go to master database management. It will have some observation ID tag and all those things. Then it will go to our payload programming system. With satellite constraints and other things, it will again send back to the input to this one. Everything will be compiled for data. Then it will also go this input to, you can say, our mission operations complex, the ground station. So what happened based on the proposals what you have submitted, there are some committees out there. They will be reviewing the proposals. They are compiling these proposals, and finally they will prepare the proposals in coordination with our recording system. Then accordingly, commands will be generated and it will be sent to the ground station to apply with the satellite. Then finally the data will come and data will be received here and processed, and then based on the locking period, then we have an integration here. Whatever locking period is set, automatically in a cyclic manner, it will be released. That is the overall cycle. So if you say this is the thing, and data will come here based on this one, MDM is having the knowledge of proposals. So this your processing will happen. In terms of proposal ID will be tagged here, and then archive, it will be archived. Based on locking period, it will be also given to the PA users for internal verification updates, and then they will be sending back the data here. They will be sending back the data to us, which would be checked against the compliance relation, whatever we have given, whether everything is received and perfect and accuracy. Then it will be archived and parallel it will be given here for Pradhan. Based on the policy, automatically it will be released for general public use. That is what is happening for ExpoSat, as well as same thing is happening for Archival. Only the proposal processing system is yet to get released, and there is another validation. So these are topical proposals, like anybody can submit proposals. There is another application called expert viewer. So expert viewer, what is doing is before submitting a proposal, you want to see a regular celestial source and when my satellite is reserved. So you can do this type of checks, target visibility analysis using that UI. So it is like an integrated activity where provides day-wise target visibility suitable for target pointing during the given start and end time. An option to download the visibility analysis output. This is required. Why? Because we can check whether this particular satellite can see this source in this period or not. Based on that, we can make a proposal and submit the proposal. Okay, this is not requiring any authentication, which is really available. But for data downloads and proposal submission, we have to log in yourself by registering. So then it is going to scheduling command generation apply. Then it is coming to payload operation, data recording onboard. It happened in onboard satellite. Then data would be played back. Then it will be received by IGC. Highlight product will be generated. If ExpoSat case, where these are the POCs and PAs. Then reception of the destination ready products at IGC and data hosting. Okay, then we will be able to download. So this is a typical chain. This is being followed. Anyway, if you see as a proposal processing system, who will connect? The mission manager, operation directors, operation controllers, system admins, committees, PI POCs, committee proposers. All these people are participating as a part of this complex software which is implemented. As viewers, you will be submitting, but there will be many things that happen as part of this one. And once you have registered into a Pradhan or maybe Chennai to restaurant, same user can do this activity also. You see, no new registration is required for this. Single sign feature is handled. The typical cycle is you have a lot of facility in this. Proposal submission, proposal review, observation planning, and data availability. You can come here and quick workflow available. You can save your proposal in the